Today we're talking about graphs with exponential functions. So we're going to first start off with the formula for exponential function, which is f of x equals a times b to the x power. Now f of x is just a fancy way to say y is equal to the y-intercept times its growth factor. But these are exponential functions that are nonlinear functions in the above form where a is not equal to 0 but b is greater than 0, where b is not equal to 0, b is greater than 0, and b is not equal to 1. Now some of the vocabulary that you need to remember is that your y-intercept is where you cross your y-axis. Instead of a slope, we're now going to be talking about a growth or a decay factor. Now you know that it is going to be a growth if you have a value that is greater than 1 and your graph will look something like this, because remember these are exponential, so they curve. It's going to be a decay if you have a number between 0 and 1, so a fraction or a decimal smaller than 1, and your graph looks something like this. The next thing that you need to remember or know is that there is a line that goes horizontally across the bottom of your graph, comes super duper close but never touches it. It's called your asymptote. Asymptote is kind of like your annoying little brother. He comes super duper close to your face but never ever touches you. It is equivalent to y is equal to 0. Again, it comes super duper close to the line, but it never ever touches. That's your asymptote. Now let's look at the example that they provided for us. We have f of x is equal to 16 times 1/2 to the x power. Now looking at this information, I know that my y-intercept is going to be in front of the parentheses, and my growth factor is going to be inside of the parentheses. So let's go ahead and answer all of these questions in this table to the right. Our y-intercept is 16. Our multiplier, which is inside of our parentheses, is going to be 1/2. 1/2 is smaller than 1, so it is going to be a decay. When we look at our graph from left to right, it's going down, which means that it is decreasing. And our asymptote, at least in Algebra 1, is always going to be y is equal to 0. Let's go to the next page and try another example. I am going to highlight the pertinent information, which is my y-intercept and my multiplier. And then I'm going to answer the questions over here to the right before I go into all of the rest of the things. So my y-intercept for this particular problem is going to be 10. My multiplier is 0.75. That number is below 1, so that is going to be a decay. My decay means that I am going to go down or decrease. And my asymptote is going to be y is equal to 0. Now let's talk about how this information will help me to both graph my information on my graph and to fill in my chart that it's asking me for over here. I already know that my y-intercept is 10, so I'm going to fill that in over here on the chart that they provided for me. And then I'm going to completely fill in this table, but I can't just do it off the top of my head. I'm going to have to use Desmos. So everybody go ahead and pull up your handy dandy calculator. We like to use Desmos. And we're going to take the information provided for us through our equation, make it a little bit bigger, and we are going to put it into Desmos just as we see it. We have y is equal to 10 open parentheses 0.75 close parentheses raised to the x power. Once I put that in Desmos, I'm going to hit the settings button that looks like a little cog, and then I'm going to convert it to a table, and it gives me all the information I need to write into my table over here on the right. It says that -2 is paired with 17.777. For this assignment, I don't want you to round. I don't want you to try and worry about any of that. Just write 3 decimals places after the decimal point. -1 is paired with 13.3 repeating. 0, which is our y-intercept, is paired with 10. I'm going to highlight that because that is always super important. And then I have 1 is paired with 7.5. 2 is paired with 5.625. Now it's asking me for 3 and 4, but I don't see it on my table. So I'm going to go over to the table and add 3. That pops up with 4.218. And then I'm going to hit enter so that I can get 4, which is paired with 3.164. After that, I'm done with my Desmos for now. From here, I can go ahead and graph this on my graph. I'm going to start with my 0, which is paired with 10. My y-intercept starts there. And then I'm going to graph all of the other things, and I'm going to connect them. I have -2 paired with 17, which is somewhere up here. -1 paired with 13.3, which is somewhere around in here. I got 0 and 10, 1 and 7.5, 2 and 5.6 something, 3 and 4.2, and 4 and 3.1. From there, I'm just going to connect all of these dots so that my exponential graph can be completed. We do not have to be perfect. We are all human. It is okay to be human and to make mistakes. Not perfect, but good enough. What I want you to do is to identify your y-intercept. And I want you to put in your asymptote. Remember, it comes super close but never touches. It is at y equals 0. And there you have it. I want you guys to try example number 2. I'm going to pause my video. You come back and see if you did it correctly. All right, friends, how did you do? You should have had a y-intercept of 18, a multiplier of 0.5, which is a decay and decrease in your graph, reading it from left to right, and your asymptote is y equals 0. This should have been your table that you received after you put this into Desmos. Let's try one more before we move on to the next page. We have g of x is equal to 6 times 1.25 raised to the x power. We know that our y-intercept is 6. Our multiplier is 1.25. So let's go ahead and fill in our table over here. Again, we said our y-intercept is 6. Our multiplier is 1.25. That number is larger than 1, so we're going to say that that is a growth. We know that growth means that it's going to go up or increase. And our asymptote is y is equal to 0. I want you to go ahead and put this into Desmos exactly as you see it. We have g of x. You can also put y, but g of x is equal to 6 times 1.25 raised to the x power. We're going to convert that to a table, and then it gives us all the information. Now on our paper it says that we start with -12, and in the chart it says we start with -2. So I'm simply going to start that over with -12, and then for my next number it says -8, and then my next number says -4, and then 0, and then 2, and then 4, and then 6. That gives us our new values that we actually care about, and we're going to fill those into our table on our paper. So -12 is paired with 0.412, -8 is paired with 1.006, -4 is paired with 2.457, 0 is paired with 6, which is our y-intercept. 2 is paired with 9.375. 4 is paired with 14.648. And 6 is paired with 22.888. After you get those numbers, go ahead and fill in your graph to the right. This is what your graph should look like in the end, making sure that reading it from left to right, it is growing or increasing. Now let's review a couple of things that we already know, but is super important when we're talking about exponentials. First, we're going to look at it when we're talking about linear equations. So we know that our domain are our x values that go with our independent values, and our range are our y values that go with our dependent values. Your domain, when writing our inequalities for the examples that are given, we know that our domain goes from left, then we write our inequality, then we give the letter for our domain, which is x, then we write the inequality and put our rightmost value. For our range, we start at the very bottom most value, then we write an inequality, then we put our y letter for range, then we write an inequality, and then the top most value. The other two things that are super important are the type of inequalities that you are going to write. If you have an open circle at the end point, you are going to have a less than or greater than sign if it is a one-way graph. If you have a closed circle, you will have a less than and equal to or greater than if you have a one-way graph. Again, greater than and equal to. So let's look at the first example. We want to start when we're looking at our graphs going from left to right when we're talking about our domain. What I like to do is to find my leftmost point, which is here, and drag it down to my x-axis so that I can find the appropriate number that that goes with. I'm going to do the same for my rightmost value, and then I'm going to write my inequality. So on the first one, my domain starts at this leftmost value, which is -9. Then I'm going to look at the end point, which is a open circle, which means that that is going to be less than. Then I'm going to put my letter, which is x, for my domain. Then I go over to my rightmost point, end point, which is a closed circle. That's going to be less than or equal to. And then I drag my dot up to that number, and that number is +2. This shows me that when I'm speaking about this domain of this graph, that I am going from -9 all the way to +2. Now let's do the same thing for our range, but instead of drawing our lines down, we're going to draw our lines in to the y-axis. So starting at the bottom, I'm going to draw my first arrow into that point. I'm going to go to the top of my graph and draw that line into that number, and then I can write the numbers and the inequality signs for my range. The first number that I'm going to write for my range is -6. I have a closed endpoint, so that is going to be less than or equal to. My letter for range is Y, and then I'm going to go to the very top and have a open endpoint, so that means it is going to be less than, and the number that I dragged my arrow over to is 3. That is how you find the domain and range of graphs. And also, this graph goes from -6 up to +3. But that is how you find the domain and range of graphs that have 2 endpoints. Now let's look at a graph that has 1 endpoint. When you have 1 endpoint, that means that it starts at a certain space and then it goes on and on and on forever in a particular direction. When we're talking about the domain and range, we want to find where it starts and then it will go on from there. So for my domain, I'm still going to draw my line down to my x-axis, and then I'm going to go from there. For your domain, you start with the letter, which is x, and then you look at the endpoint. This endpoint is closed, so I need to figure out if it's going to be less than and equal to or greater than and equal to. The way I figure that out is by figuring out if my numbers get bigger or smaller. This time they're going in this direction, so all of my numbers are getting bigger, which makes this greater than or equal to -4. For my range, I'm going to draw my line into my y-axis, and then I'm going to figure out if the numbers get bigger or smaller by following the direction of that arrow. This one's going down. So I'm going to start with my range with the letter Y. I'm going to say that these are going to be less than or equal to, and then I'm going to look at the number that I drew it into, which is +6. Now let's see how this relates to exponential functions. In our first example, we have 2 endpoints. So I'm going to start with identifying where those go on my x-axis. I'm going to draw from the left-hand side straight down and the right-hand side straight down. I know that my domain is my x value, but let's see where we begin. On the left, we start at -2. I have a closed endpoint, which makes this less than or equal to, then my x. Then I'm going to look at this endpoint, which is open, which makes this less than, and I'm going to follow that arrow down to the number where it ends at +3. So my numbers go from -2 to +3. Now let's look at our range. Your range goes from the bottom to the top, and the first number that I went to on the bottom is +2. I have a closed endpoint, which is less than or equal to. My letter is Y for range. Then I'm going to the top endpoint, which is open. That is going to be less than, and the number that we drag it to is +12. So the information that I just wrote says that my range goes from +2 to +12. Now, what I want you to do is I want you, with all the practice that you've had, go to your next example and do it on your own. I'm going to pause the video, come back after you're finished to check your answer. How did you do? I hope you did great. Let's look at this one together. This is kind of what a star question is going to look like. You're going to use the same tactics you did on the other. You're going to first look for your domain, which is your x-axis. This is a one-sided inequality, so you start at -2, and you know that it's your x value. So let's look over to the right with our answer choices. The answer choices on the bottom are for your domain. So any of them that are not associated with -2 need to be marked out. This cannot be a correct answer. Now I also know that my domain goes from left to right, and this one is going to the right. It is getting bigger, which means that it should be greater than. Now this circle or endpoint is also closed, so it should be greater than and equal to. So that eliminates this one and this one, and my correct answer is the one on the bottom. When we're talking about our range, we know that our range goes into our y-axis. That is approximately at 1.5. We know our range is our y values. So any of these that aren't associated with 1.5 have to be wrong. We also know that the arrow is going in the up direction, which means it is getting bigger. Since both of these have greater than, we have to look at our endpoint. This one is closed, so I should have the line underneath it, which means that this one is incorrect and this one is correct. One last question before I let you do all of the rest on your own. It says a part of the exponential function describing cell growth over time is shown on the grid. Which two statements best represent your domain and range? I am going to separate them like I did the last time. And then we're going to get into what our graph actually looks like. Your domain goes from left to right, but we know that this is a one-sided graph. And this one starts at 0. And it's going to the right, so all of the numbers are getting bigger. So let's look at our answer choices for our domain. The first one says the domain is the set of all real numbers greater than or equal to 0. That sounds promising. The domain is a set of all real numbers less than or equal to 0. Well, we know that they're not getting smaller, so that cannot be the answer. The domain is a set of all real numbers greater than or equal to 20. Well, 20 is not the right number, so we know that the first answer choice was correct. Now let's look at our y-axis, or our y values, which is our range. Our range goes into our y-axis, which looks like it's right about at 10. And then this graph is growing exponentially or going up. It's increasing. So let's look at the answer choices provided. It says the range is a set of all real numbers greater than or equal to 10. Okay, maybe. Let's keep that one in mind. It says the range is a set of all real numbers greater than or equal to 20. Well, we know 20 is not where it starts, so it can't be that one. It says the range is a set of all real numbers less than or equal to 10. Well, it's not less than, it's not going smaller, so the first answer choice is correct. If you have any questions on how any of this works, please let me know.